Section 300.5d of the 2004 California Electrical Code, which aligns with the 2002 National Electrical Code, addresses underground installations. Specifically, it places restrictions on the use of non-metallic sheath cable, commonly known as NM cable, when installed in a raceway that is buried at a depth exceeding 20 inches. This section is crucial for ensuring the safety and longevity of electrical wiring systems in underground applications. The primary reason for this restriction is that NM cable is not designed to withstand the harsh conditions present in underground environments. These conditions include exposure to moisture, chemicals, and physical stress, which can degrade the cable's insulation and lead to electrical faults or failures. When NM cable is installed in a raceway buried deeper than 20 inches, the risk of these issues is significantly increased. Therefore, the code mandates the use of wiring methods that are specifically designed and rated for direct burial or installation in wet locations. This helps to prevent premature cable degradation and ensures the safe and reliable operation of the electrical system. Section 334.10 of the 2004 California Electrical Code, again mirroring the 2002 National Electrical Code, further clarifies the requirements for underground raceways by specifying the use of individual THWN conductors. THWN is an acronym that describes a specific type of insulation commonly used on individual electrical conductors. The letters stand for T, which indicates that the conductor is thermoplastic insulated, H, which means it is heat resistant to 75 degrees Celsius, W, which signifies that it is suitable for wet locations, and N, indicating that it is nylon coated. THWN conductors are designed to withstand the rigors of underground environments, including exposure to moisture, chemicals, and physical stress. Unlike NM cable, which has an outer jacket that can be compromised in wet or corrosive conditions, THWN conductors have individual insulation that is specifically formulated to resist these elements. This makes them a much more reliable choice for underground raceways. The requirement for individual THWN conductors in underground raceways stems from the need to ensure that the wiring system can withstand the harsh conditions present in these environments. When conductors are installed underground, they are constantly exposed to moisture, which can seep into the raceway and cause corrosion or insulation breakdown. Additionally, underground soil often contains chemicals that can degrade the insulation of ordinary cables. By using THWN conductors, these risks are significantly reduced. The nylon jacket of THWN conductors provides an additional layer of protection against moisture and chemicals, further enhancing their durability and reliability in underground applications. Furthermore, the individual insulation of THWN conductors allows for easier identification and maintenance of the wiring system. When conductors are bundled together in a cable, it can be difficult to trace individual wires or make repairs. With individual THWN conductors, each wire is clearly marked and accessible, simplifying troubleshooting and maintenance procedures. In summary, the 2004 California Electrical Code and the 2002 National Electrical Code prohibit the use of NM cable in underground raceways buried deeper than 20 inches to prevent premature cable degradation and electrical faults. Instead, the code requires the use of individual THWN conductors in underground raceways to ensure the safety and reliability of the electrical system. This combination of restrictions and requirements is designed to provide a robust and durable wiring system that can withstand the challenges of underground environments. When planning an underground electrical installation, it is crucial to carefully consider the applicable code requirements and select wiring methods that are specifically designed and rated for the intended application. Failure to do so can result in safety hazards, premature equipment failure, and costly repairs. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installation complies with all applicable codes and standards. The depth restriction of 20 inches for NM cable in underground raceways is a critical safety measure that should not be overlooked. This depth is considered a threshold beyond which the risk of cable degradation and failure is significantly increased. When a raceway is buried deeper than 20 inches, it is more likely to be exposed to higher levels of moisture, chemicals, and physical stress. These conditions can accelerate the deterioration of the NM cable's outer jacket and insulation, leading to electrical shorts, ground faults, and other potentially dangerous situations. The use of THWN conductors in underground raceways is not only a code requirement, but also a best practice for ensuring the long-term reliability of the electrical system. THWN conductors are designed to withstand the harsh conditions present in underground environments, providing a durable and reliable wiring solution. Their individual insulation and nylon jacket offer superior protection against moisture, chemicals, and abrasion, making them an ideal choice for underground applications. In addition to the specific requirements outlined in sections 300.5d and 334.10a, it is important to consider other factors when designing and installing underground electrical systems. These factors include the type of soil, the presence of groundwater, the expected load on the circuit, and the potential for physical damage to the raceway. The type of soil can affect the rate of corrosion of metallic raceways and the degradation of cable insulation. Soil that is high in acidity or alkalinity can be particularly corrosive, requiring the use of special protective coatings or materials. The presence of groundwater can also accelerate corrosion and insulation breakdown. If the raceway is constantly submerged in water, it is important to use conductors and raceways that are specifically rated for wet locations. The expected load on the circuit will determine the size of the conductors required. It is important to select conductors that are large enough to carry the anticipated current without overheating. Overheating can damage the insulation and lead to electrical faults. The potential for physical damage to the raceway should also be considered. If the raceway is located in an area where it could be struck by heavy equipment or vehicles, it should be protected by a concrete encasement or other suitable means. In addition to THWN conductors, there are other types of conductors that are suitable for underground applications. These include XHHW, which stands for cross-linked polyethylene, heat-resistant, wet location, and use, which stands for underground service entrance. XHHW conductors have a higher temperature rating than THWN conductors and are often used in high current applications. Use conductors are specifically designed for direct burial and do not require a raceway. However, they must be protected from physical damage by a layer of sand or gravel. The choice of conductor type will depend on the specific requirements of the application. It is important to consult with a qualified electrician or electrical engineer to determine the best conductor type for your needs. In conclusion, the 2004 California Electrical Code and the 2002 National Electrical Code provide specific guidelines for underground electrical installations to ensure the safety and reliability of the system. These guidelines include restrictions on the use of NM cable in underground raceways buried deeper than 20 inches and requirements for the use of individual THWN conductors in underground raceways. By following these guidelines and considering other relevant factors, you can create a robust and durable underground electrical system that will provide years of reliable service. Always remember to consult with a qualified electrician or electrical engineer to ensure that your electrical installation complies with all applicable codes and standards. This will help to prevent safety hazards, premature equipment failure, and costly repairs. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities as the basis for their electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, electrical engineers, and anyone involved in the design or installation of electrical systems. The NEC is not a law itself, but it is often adopted by state and local governments as part of their building codes. This means that compliance with the NEC is legally required in many jurisdictions. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work, such as wiring methods or grounding. Each article provides more detailed requirements for a particular topic within that chapter. Each section provides specific rules or guidelines for a particular situation or application. To use the NEC effectively, it is important to understand its organization and terminology. The NEC uses a variety of technical terms and abbreviations that may be unfamiliar to those who are not trained in electrical work. It is also important to understand the difference between mandatory rules and permissive rules. Mandatory rules are indicated by the word shall and must be followed. Permissive rules are indicated by the word may and are optional. The NEC is a complex and comprehensive document, but it is essential for ensuring the safe installation of electrical wiring and equipment. By understanding the NEC and following its requirements, you can help to prevent electrical hazards and protect yourself and others from injury. In addition to the NEC, there are other codes and standards that may apply to electrical installation. These include state and local building codes, as well as standards developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of all applicable codes and standards when designing and installing electrical systems. Compliance with these codes and standards is essential for ensuring the safety and reliability of the electrical system. Failure to comply can result in fines, penalties, and even legal action. In conclusion, the installation of electrical wiring and equipment is a complex and potentially dangerous task. It is important to be properly trained and qualified before attempting any electrical work. Always follow all applicable codes and standards and consult with a qualified electrician or electrical engineer if you have any questions or concerns. By taking these precautions, you can help to ensure the safety and reliability of the electrical system and protect yourself and others from injury.